Okay, guys, let's start. So, yesterday we saw what? Disk washer and disk method and washer method to get the volume of the given region. First of all, we saw the area under the curve, and then after we started the volume and share the screen. Okay, we start the volume. Look at here. First of all, we find the area enclosed by two curves. And I told you that always we are moving from right side to left side and then top to bottom. If you are given two functions f and g, so you can interchange those two functions related to your region. Upper part of the function, the strip touches the upper part, that should be your fx, and the bottom part, that should be your gx. You can always play with these two functions. You are not allowed to change the function, but you can just play with this one. So you can interchange this one. And then after we use the formula area A equal to integration A to B fx minus gx. Also, I told you that whenever we have nature of the strip changes the behavior, either upper part or the lower part, at that time, we have to divide our region into two parts, right? Whether it is vertical strip or horizontal strip. Vertical strip means we are integrating with respect to x, and horizontal strip means we are integrating with respect to y. So all these things we have discussed yesterday, and then after we started the volume. And volume, that was first with respect to, this is the practice test assignment 2. I'm going to put the separate practice test assignment, same thing for article 7.1, 2, 3, and 4 in your file folder in Canvas. Yeah, so you can go through these problems, and then not area enclosed by the curve, not this, okay. What is this? Yeah. So we went over these examples, and then after I told you that if you take vertical strip or horizontal strip, in both cases, you must get the same answer. If range of integration is same, I mean to say that, I mean to say that if you are revolving your figure around x-axis or x-axis, and if you are taking, suppose, horizontal strip means integration with respect to y, or vertical strip with the integration with respect to x, in both the cases you must get the same answer. If you are revolving your figure around y-axis, means if axis of revolution is different, you may get different answers. But if axis of revolution is same and you are revolving, I mean say, the same area, in that case, either x or y axis, I mean to say, either vertical strip or horizontal strips, both ways you must get the same answer. And I took a couple examples based on that one too. Okay. Then after I told you that axis of revolution should not be always the same, or x or y axis, it could be anything else too. Look at over here, one of the examples we took here, that was the axis of revolution, that was y equal to 4. So that's why always we are coming from top to bottom. So my ry in this case, or rx, sorry, that was, yes, top part, that is 4 minus this one, 4 minus bottom, and small rx is 4 minus this curvature. So please make sure always we are coming from top to bottom. Here we did the same thing. Look at here, the top to the, oops. So top to bottom, look at over here too, that this is my capital R X here to 0, and then small r x are equal to y equal to 1 to 0. So please keep in mind this thing, guys. Please keep in mind these things. And then after we started cell, I mean to say, this is just the, okay. So we started volume by disk and washer method. Is it the same file we used yesterday? I don't know. Area enclosed by two curves. Let me double check, guys. Yeah, I think, this is the same file we used yesterday. Okay. Now area enclosed by two curves. That is just a repetition. just the repetition of different examples. Just try to go through these examples. This is one of the good examples to get y equal to x and y equal to root x like this. So if you follow this type of example, they're simple examples, but you can see both the ways we are getting the same answer. So many examples I solved by both ways so that you can realize this thing that we must get the same answer. Okay, then after this is the formula sheet. You can take the printout of this formula sheet, page number 32. Take the printout of this formula sheet. Yes. Here I said that horizontal axis of revolution, disk method first. Disk method means strip, or washer method, strip must be perpendicular to the axis of revolution. So horizontal axis of revolution, capital of Rx square dx. Vertical axis, I meant to say, yeah, horizontal axis of, and this is a vertical axis of revolution, y equal to x equal to 0, x equal to 1, 2, 3, like this. That means horizontal strip. That means we have to have horizontal strip means integration with respect to y. Then after washer method, when your strip does not touch the axis of revolution, for horizontal axis of revolution, you are writing rx square minus small rx square and dx. Here it is ry square and small ry square dx. Here it is vertical strip. Here it is horizontal strip, because axis of revolution is this one. Okay, that's what we finished yesterday. And today we are going to see the cell method, another way of finding the volume, of the given region or bounded by between two curves. Horizontal axis of revolution, now it is slightly different. Look at the formula, horizontal axis of revolution. Now your strip must be parallel to the axis of revolution. For disk and washer, your strip was perpendicular to the axis of revolution. For cell method, your strip must be parallel to the axis of revolution. Because my axis of revolution is x-axis, I have to have the strip parallel to x-axis. Means you can see over here the horizontal strip. Horizontal strip means again the same thing, you are integrating with respect to y. Suppose my axis of revolution is y. That means you have to have one perpendicular strip which makes, I mean to say, the strip is parallel to the axis of revolution. Because it is perpendicular strip, and that's why you are integrating with respect to x. The formula to find the volume by cell method is b equal to 2 pi range of y, because horizontal strip integration with respect to y, py hy dy. So what is py? Py is nothing but the distance from the strip to the axis of revolution. Look at over here, px or py, distance from the center of the strip or strip to the axis of revolution. So here this distance is my py. My px will be distance from the center of the strip to the axis of revolution. If your axis of revolution, suppose x equal to 4 here, that means I'm going to find distance from the center of the strip to the axis of revolution means this side. So be careful, guys, be careful. I'm going to take different varieties of examples over here too, but please pay your full attention. I'm extremely disappointed by grading your test too. So many times I've been telling you, please just give me one file. But the first guy, he put several files, 8, 7, 9 files. Who is going to check these things? Don't do this thing. So many times I told you. And I gave you ample opportunity to, my canvas was open till yesterday night. I sent the message to everyone. If you have not utilized that time, if you have not followed me, if you have not followed my instruction, then I think nobody can do anything for you. Niktun, whenever you leave, please let us know. Or any one of you, if you are leaving the meeting, please let us know first before you leave. That's fine. Now, yeah, some of you have submitted only the exams, but they didn't bother about the homework. I extended time period, even though if you are eager to lose your points, that's fine with me. I can't help you out. I'm sorry. So many times I reminded you, I extended my time. I gave you the solution before a night of the exam. And even though if you are not serious, I'm sorry, no one can help you out. If you are not sincere about your course, and if you want to fail this course, I'm extremely sorry, guys. I can't do anything. I'm trying my best right now, but I think you guys are not that sincere. You guys are not that cooperative. Sorry, guys. Sorry. Or let me know what else I can do for you. It's a lengthy syllabus. I have to maintain a little bit of speed. Yes, to finish the syllabus in time. You have chosen this summer course. Nobody invited you. You have chosen this summer course. That means every day 2 hours teaching, and 2 hours teaching means I told you very first day that you have to put at least 3 to 4 hours a day, but you are not. It clearly looks. So how many times you want me to waste my time and just to give the advice? That's not going to happen every time. Be sincere. Otherwise, I'm sorry. I told you that this chapter was really very important and people are messing up that exam. So many times, that's our previous experience. That's not just my class, every class is. Even though you did not pay attention. I try to give you lots of extra points too. Yeah, so that at least you can reach up to C. But see, somebody is extending his hand to help you out. But if you don't want to extend your hand, it's not going to happen. Anyway, my job is to satisfy you guys, just to teach you, because that is the student's attitude. If they are not doing well in the course, that means always they are blaming the teacher. Yeah, that's the student's attitude. I don't know what's about you guys. I really don't know. But please, guys, be careful. This is first experience for all of us for online teaching and all these things. But now we have to be habituated because so far the vaccine has not been investigated. It's not been investigated. So yeah, we have to keep distance. We have to accept the situation, I would say, and we have to move ahead. Yeah, world cannot stop. So please try to cooperate yourself, please. I don't say try to cooperate me. Try to cooperate yourself, guys. After giving complete solution of the practice test, if you are messing up the exam, who help you out? I don't know. Anyway, let's go ahead. If somebody wants, just decide in between those who are below 70. And if they want to improve, if they want to go for the retake, I don't mind. I will give you retake. You are bothering me. Yes, honestly, I'm telling you. Lots of work for me. But even though I think I need to find some time for you again. Yeah, I'm working almost every day, 5, 6, up to 5 p.m., 6 p.m. every day. And then after just 2-3 hours rest I have. And then after I go to bed. But that's fine. I can find some time. I can work for you at night too. The main thing is you must be willing to work for yourself. Anyway, guys, I don't want to upset in the early morning. So again, just decide in between. Try to set up the Zoom meeting by your own. Don't include me, please. And let me know about your decision. If some of you, those who got less than 70, want to go for retake. So please let me know this thing. Otherwise, sorry. And you can take your retake probably tomorrow. If those who want to go for retake. Yes.
Would that be just for test 2 or test 1 as well?
Right now, test 2, and then after we'll think about test 1 too. Who is there? Judith?
Yes, sir.
Okay. I know which things are to be given more importance, and since yesterday I decreased my speed because I know these things are not that easy. And I can see your faces too. This is my 23rd years of teaching experience. So I can see your faces and I can come to know what you guys have done yesterday. So many, I can see your faces. So many of you have not seen them, did not look at the notes, whatever we did just yesterday. They have not tried anything. Okay, fine. Anyway, guys, still you have time. After a couple of days or after this weekend, you will be out of time. Yeah. Nobody is going to give you any advice because we will be running out of time then after. It's not going to happen. Still you have time. You realize your time. It's just 3 days. Okay.
Sir, I have a question real quick.
Who is there? I told you first speak your name and then after. Who? Jeremy? I can't hear you. What's your name?
Here, sir.
Okay, go ahead.
So I was one of the students who got the email that my exam and homework wasn't submitted. But then later I saw that the homework had been graded.
Yes,
So
because I
I
found
just
your homework at that time. I was
in
not
the comments.
open your homework. So I found your homework almost, I would say, around 6 p.m. Something was wrong with the system probably. So I found your homework and I graded your homework. But still,
Oh,
the exam is not there.
okay. You know, I can try to submit it again. But I've submitted both of them, and I know I had the same problem last test. So I can for the next test, or I can try to email it as well.
Don't email me. Don't email me.
Okay.
You have to submit your exam on Canvas. If you don't know how to submit, take the help from these guys. All are really very good.
I have, sir, and on my end, everything looks fine. It looks like I have it submitted. So I'm not trying to create more work for you, sir. I just want to turn the
See,
exam
Nick,
in.
I don't mind if you send your exam to my email. I don't mind. But in that case, I won't be able to grade your exam. You will be able, I mean, I can grade your exam, but you will be able to see only the number. You won't be able to see at which point you made the mistake. That's the only problem. And that will not be in the record too. If you're submitting on Canvas, that means that is the record for me as well as you, right? So please try to learn that thing, try to practice something. And yeah, I can open your Canvas. I can open the Canvas today also if you want, because the time period was over yesterday night. But again, yeah, if you want, I can open the Canvas.
Okay, yeah, I just thought since you found the homework, you would have found the test. I'm not sure.
Once you received my message, you should have tried immediately, because deadline is there, right? 2 times I extended the time period.
Right. So I saw the second message that the homework was 8 out of 10, and then I saw the first message. So I thought, oh, maybe he graded the homework and the exam's coming. So
Not the
I thought he
exam. Otherwise, why not exam? I would have graded your exam too, but I could not find it. Anyway, do it. Okay, guys. So yeah, so px is nothing but the distance from the center of the strip to the axis of revolution, and each y or each x, that is nothing but the length of the strip. That is nothing but, you can see over here, that is the height of the strip. You can say height of the strip. Okay, good. First example, again, I would like to revise. Look at over here, guys. This page is very important. Again, you will not find this type of page in any of the books. This page is really, very important. Why? Because now, I told you just now, if you remember, just before 10 minutes, I told you that I like this type of examples. Looks very simple example, and it is. Y equal to root x and y equal to x about x-axis. Use Disch-Wasser method. Y equal to root x means y square equal to x means parabola. Y equal to root x is a parabola in the upper quadrant. I mean, it's the first quadrant, upper part of the x-axis. And y equal to x line passes through origin. The y equal line passes through origin. About x-axis, axis of revolution. Disch-Wasser method, my strip has to be perpendicular. Because strip does not touch the axis of revolution, we have to use the Wasser method. See, everything should be in your mind very quickly. Then I am using the formula v equal to pi integration rx square, small rx square, and dx. So what is my capital Rx? Capital Rx is nothing but the top part of the strip to the axis of revolution. Here it is root x. So root x minus x whole square. Lower part, small rx, x square, x minus 0 square. So it is x square. If you solve these two equations, y equal to root x and y equal to x, you're going to get point of intersection means x square minus x equal to 0, x equal to 0 and 1. So if you plug these values in any one of these two equations, you're going to get the values of y. So it is 0, 0 and 1, 1. So that these two are the point of intersections. We are integrating with respect to x. That means x runs from 0 to 1. So limit of x is 0 to 1. And then after just solve this one, you're going to get pi by 6 as the answer. That's the volume. That's your volume. Now, I want to use the same example. Y equal to root x, y equal to x about x-axis. Same example, same axis of revolution. I'm not changing axis of revolution. And I would like to solve the same example using cell method. Cell method. So y equal to root x. Trust me, guys, no one is going to teach you like this. I know I already went through this type of things yesterday, but still I just would like to spend some time because of you guys, just for you guys. Right? Because you can see here, my axis of revolution is changed. Same example, axis of revolution is changed. My answers are different. Same example and same method was there. Same example, my axis of revolution is same. And I'm changing my method both ways. I must get the same volume. Volume cannot be changed if your axis of revolution, your bounded region, everything is same. Right? Look at here. Here it is pi by 6. Here is 2 pi by 15, 2 pi by 15. That's why I told you, if you are done with this page, you are done with both the methods. Because everything that is included in this example, just one example, or I would say one example by two different axes of revolutions, we are done. Work hard, guys. There is no any other alternative. Work hard. It's not like this that I'm just advising you right now. No, I really worked hard in my life, and still today I'm working hard. Yep, daily I'm working 5 hours teaching, another 5 to 7 hours for my work, for your grading, all the stuffs. Daily I'm working 10 hours. Yep, even right now, nowadays also I'm working 10 hours a day. So anyway, your choice. Okay. Oops. Technology bothers. Okay, guys. So let's go for this one now. Now, cell method. Axis of revolution is this one. That means I have to have strip parallel to the axis of revolution because that's what this method demands. So horizontal strip means integration with respect to y. Integration with respect to y. Here we went from top to bottom. Look at this arrow. Here we have to go through most right side to left side. So here it is y equal to root x. Here equal to x is equal to y. Most right side is this one. So this I would say fy, and this I would say gy. So fy minus gy, something like that. So this is nothing but my distance, my length of the strip. Here to here is my length of the strip, right? Here to here, that's the length of the strip. Here is nothing but horizontal strip means you have to have function of y. So it is x equal to y, but I would consider y equal to x. Here it is y equal to x, root x means I have to have x equal to y square because it has to be function. It has to be the functions of y, both of them. So here x runs from y to x runs from y square. So it is y minus y square. So hy is nothing but y minus y square. Is hy equal to y minus y square, right to left, y minus y square. And py is nothing but the distance from the center of the strip to the axis of revolution. Center of the strip, that is, what is this? This is the equation py equal to, this is x equal to y, and this is, y, yeah. So x equal to y. Agree, guys? And this is the axis of revolution, that is my y equal to 0. So you can see over here, this is simply y minus 0. Y minus x-axis, so that is equal to 0. So we are getting like this, py equal to y, py equal to y. Always think like this, axis of revolution. We don't know this distance, and that's why I would say that is equal to y. Why? Actually, I'm not taking any x equal to y or like this. No, I'm not using this equation. I am taking, please be careful, I'm not taking x equal to y, this y over here. No. I'm just assuming that this distance between from the center of the strip to the axis of revolution is simply small, some y distance. Why some y distance? Because I chose this strip over here, but it could be over here, 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 it could be anywhere in the defined region, right? So it is some distance, some vertical height, some height y. And that will work. Look at over here. This is y and y minus y square. So it is, if you multiply this one, so y square minus y cube, integration gives you y cube by 3 minus fy to the power 4 by 4. Range of integration is 0 to 1. Plug the values. See, y is replaced by your upper limit and the lower limit. You are getting 5 by 6. See, now y is gone, or all y's are gone. So pi by 6. Right, guys? Right now, your axis of revolution is simply like this. So that's why this example is very simple. But suppose my axis of revolution here, in this case, y equal to 0. But suppose x-axis, y equal to 4. You have to be very careful at that time. I will let you know. I will let you know. Right, at that time I'm going to consider this one as y. This whole distance is 4, so this distance will be 4 minus y. So axis of revolution, py in that case will be distance from the axis of revolution, distance from the center of the strip to the axis of revolution, that will be 4 minus y, something like that. Wait, I will let you know. Right now, just pay attention here. Now, same example, axis of revolution is y-axis. So I just changed the axis of revolution. I was revolving my figure like this. Now I am revolving my figure like this around y-axis. That means strip must be perpendicular in Wasser method. So I have to have the function of y. So here it was given y equal to x. I'm writing x equal to y. Here it was given y equal to root x. I'm writing x equal to y square. X equal to y square. Most right to most left side. Okay. Please keep in mind this thing. Okay. Now ry is nothing but the highest top part, top right to the axis of revolution. That is my ry. So ry, this is my y because x equal to y. So y minus c is 0, right? So x equal to y to x equal to 0. X equal to y to 0. So my ry equal to y to 0. Y minus 0. Good. My small ry is this one. Look at my cursor. My small ry is this one. Here x equal to y square. So y square minus 0. So y square minus 0. Plug the values. Rx square. That is y. So y square. Ry is y square. So y square and square. So y to the power 4. Here cube by 3, 5 by 5. Outside it is 2. Please keep in mind this thing whenever you are using Wisk and Wasser method. At that time you are multiplying by pi. But in cell method you are multiplying by 2 pi. So please keep in mind this thing. That's the formula. That's the formula. And that's why I told you to take the print out of the formula sheet for your exam.
Sir, I have a question. Actually,
I'm waiting. I'm waiting.
never mind. Sorry, that was a mistake.
Okay. Good. So if you solve this one, you're going to get 2 pi by 15. Now y equal to root x and y equal to x about y-axis. Same example. Only thing, I'm changing my method. You know guys, it is something like that. Suppose you want to, again the same example. Suppose you want to go to Interstate 81 from VMI, right? So one way to go to 81, that is use route 11 and take the exit 195 and you can go to Interstate 81. Second one is you can take the turn to take route 11 and then take a right turn for Interstate 64, right? And then Interstate 64 is merging to Interstate 81 at the exit 191. So again, you will be reaching at the same point. So if you are going through this route or this route, if your destination is same, if your example is same, if you are using two different methods, two different routes, you must get the same answer. You must be going through the same destination. Are you getting me, guys? Right? It is something like this. Y equal to root x, y equal to x about y-axis. Now axis of revolution is my y. I'm using cell method. Means my axis, my strip must be parallel. Parallel means I don't have any other choice. I have to draw the vertical strip. Vertical strip means I am integrating my function with respect to x-axis, right? That means everything should be in terms of, should be a function of x. Good. Here, this one is given, curvature is given to us y equal to root x. It is already given in terms of function of x. This is y equal to x, so this one is y equal to x. Okay, this hy is nothing but the length of the strip, right? Length of the strip means it is, we are coming from top to bottom. So root x minus x. So root x minus x is my hx. And my px is nothing but the distance from the center of the strip to the axis of revolution. And usually, because as I told you, this distance, because it is along x-axis, that means I would like to consider this as x. In the previous part here, it was just y, because it was along y-axis. Now it is along x-axis. So I would like to say px equal to x or x minus 0, like this. So I fixed my px, I fixed my hx, integration range. Once you solve these two equations, that remains same. The point of intersection remains same for all figures. So that's why it is 0, 0 to 1, 1. Because I'm integrating with respect to x, so I have to consider the x ranges. So x goes from 0 to 1. X goes from 0 to 1. So 0 to 1. And 2 pi, that is the formula. So 2 pi times this one. Just multiply this one with this one. So x to the power 3 by 2 and x square 5 by 2 divided by 5 by 2 and x cubed by 3. Range 0 to 1. Second fundamental theorem of calculus, 2 pi by 15 is the answer. So both are same. Any doubt in this example, guys? Any doubt? If you have any doubt, you can ask me, guys. So many times I told you.
Good, sir.
Good, sir.
Thank you. Girls, are you good?
Good, sir.
Next method, next one. Now I'm changing slightly my axis of revolution. Find the volume of the solid formed by revolving the region bounded by fx equal to y equal to 2 minus x square. 2 minus x square is a parabola passing through the point 2. Because it is negative x square, that means parabola opens down, right? It's a dome like this. And 2 minus x square, that is this parabola, of course. Then y equal to, I don't say fx and fy or gx, fx and gx. No, I would say just y and y. And accordingly, I will change my Nick tone here, please. Nick tone here. Here, please.
Sorry, sir.
Bothering you, say him or her to go outside, please. Anyway. What I was telling you. Okay. So, these two are the functions. So y equal to 1. Y equal to 1, now my line is this one. Line y equal to 1, that is this one. Right? About the line y equal to 1. So now my axis of revolution is also same. Y equal to. So it's not my x-axis, it's not y-axis, it's something different. But again, my strip touches the axis of revolution. You can see over here because this is the axis of revolution. So we are using disk method. See, I wrote it down Wasser, I cancelled it. And because you can come to know this thing that why not Wasser, strip touches the axis of revolution. Okay, that means my formula is simply Rx square. So how can I find my Rx? My Rx is nothing but the length of the strip, that means top part to bottom part. So 2 minus x square minus 1. Don't forget this, y equal to 1. So y equal to 2 minus x square here to here. 2 minus x square minus 1. So it is 1 minus x square. So let me plug it over here and just simple calculation gives you the answer. Simple. Now, suppose for the same example, see, that's what I'm doing, and that's what I would love to do this thing. I just want to check myself using separate different method too. So my cell method now, I told you, you will not find, at the most you will find probably one example, same example by both the methods, maybe in hardly 1 or 2 books, but not multiple examples like this. And that's what I have done over here. Yeah, it's not like this. I spent lots of time for this one. Lots of time. I'm working for you guys. Please, now you are done. Okay, guys. Same figure, y equal to 1, but instead of disk, now cell method. Why I chose this example? Because previously it was Wasser method. Wasser I converted to cell. Now it is disk, I am converting to cell. You can do that thing, yes. Good. So this is my figure. Now I am using, this is my axis of revolution. I am asked to use the cell method. Cell method means my axis of revolution must be parallel. My strip must be parallel to axis of revolution. This is my strip, axis of revolution. So I have to have the horizontal strip. Horizontal strip means I am integrating with respect to y. That means all my functions should be in terms of y. All of them. Both of them must be a function of y. I am given y equal to 2 minus x square, but I have to have the function of y. That means I have to write x equal to some function of y. So if you take this x square other side, so it is 2 minus y, and then because it is, look at over here, see, Okay, let me explain to you. Here it is y equal to 2 minus x square. So what is x square? X square equal to 2 minus y. So what is your x? X equal to plus or minus square root of 2 minus y. Don't forget plus or minus. Plus side. On your right side of your y-axis, function is a plus square root of 2 minus y. On the left side of your y-axis, it is negative of square root of 2 minus y. I did one example like this yesterday too, if you have gone through it after my class. Anyway, so that is important thing, one thing. Second thing, this is my axis of revolution, and now my formula says that I have to find Py and Hy dy. What is my Py? My Py is nothing but the center distance from the center of the strip to the axis of revolution. Center of the strip to the axis of revolution means just simply this one. Agree, guys? Center of the strip to the axis of revolution. Center of the strip, that is this one. Where is it? Py is equal to, yes please. Oh, sorry. Yes. So Hy is nothing but now most right to most left part. That means here it is x equal to square root of 2 minus y minus x equal to negative of square root of 2 minus y. So minus and minus will become plus. Look at here. So it is 2 times square root of 2 minus y. So that is my Hy. That is my Hy. And what is my Py, guys? Py is, yes please, Py is equal to, look at here, this distance, Py equal to the distance from the, here to here. I told you, distance from the center of the strip to the axis of revolution. Now, usually what we are taking, usually from this, please pay attention, guys, otherwise you will be wrong. Please pay attention. Be alert. Usually we are taking distance from the center of the strip to either x or y axis. If it is x axis, I would consider this one as y. Did you remember the last example? Look at here. The distance I just considered as y, Py equal to y. Because I told you my strip could be over here, it could be over here, it could be over here. So that is we are related to somewhere over y, somehow on y. And that's why I consider Py equal to y. Same theme here. My Py is center of the strip to my y-axis is here. This distance, that is usually that is y. This distance is y. But this distance is 1. This distance is 1. So what is this distance? Center of the strip to the axis of revolution. Yes, it is y. Whole distance is y minus 0. Whole distance is y minus 0. And this distance is 1. So I have to remove this y minus 0 to get the distance from the center of the strip to the axis of revolution. So it is y minus 1. Are you getting me? If you are not following me right now, you will be getting lots of troubles after the class. If you have any doubt, you can ask me. I'm waiting. Or let me repeat. Axis of revolution, just like previous example, the distance from the center of the strip to either x or y axis, usually we consider as y or x. Here it is y, horizontal strip, y. From the center of the strip to x-axis. But Py is nothing but the distance from the center of the strip to the axis of revolution, this one. And this axis of revolution, that is y equal to 1. That means this 1, whatever 1, this distance, 1 point up, I have to remove to get this distance. But this distance was here to here was y. This is 1. Let me remove this one. So y minus 1, that would be my Py. And once you have your y minus 1, just plug the values over here. Multiply this one. Term by term integration will give you the answer. That will give you the answer. Simple. Please be careful, guys. Sometimes people are getting confused choosing your Py, describing Py. One nice example again, and by both the ways. Look at here. Find the volume of the solid perform by revolving the region bounded by the graph of the function y equal to x square plus 1. Y equal to x square means parabola passing through origin. Parabola up, right? Because it is plus sign, so x square. Plus 1 means parabola is holding 1 point above on y-axis. So parabola passing through 0, 1. Y equal to 0 means x-axis. X equal to 0 means y-axis. X equal to 1 means perpendicular line. If you solve these two equations, x square plus 1 and x equal to 1, so x square plus 1 equal to 1, so x equal to, yes please, right? If you solve these two equations, you are going to get that is equal to, yes please, yeah, x square plus 1 and x is equal to 1. So x equal to 1, x equal to 1, if you plug it over here, 1 square is 1, 1 plus 1 is 2. So when x equal to 1, y is 2. So this is the point of intersection 1 and 2, right? And this is naturally my y equal to 0 and x is equal to already 1, so it is 1, 0 point. So I fixed my this point, I fixed my this point. This point is already y equal to x square plus 1 gives us this is 0 and 1 because 1 point above on y-axis, x is 0 on y-axis means so it is 0, 1 point. And if you take this dotted line, I want this one, I will let you know why. And this point is 1, 1. Why 1, 1? Because y is already 1. Look at over here. Y is already 1. And my x is already 1. Look at over here. This is a line. So it is 1 and 1 point. Don't get confused, guys. 1 and 1 point. I fixed my points. And this point, all these points remain same for both the methods because they are just the point of intersections. Right? So my figure is this one. I am looking for the volume of this region, First of all, I want to use the disk or washer method. This is the example of disk and washer combination. That's the reason why I took this example. Combination of disk and washer. Why? Look at here. About y-axis. About y-axis means this is my axis of revolution. Axis of revolution is y. That means my strip, and I'm using washer and disk. That means my strip must be perpendicular. If you want to draw the perpendicular strip to y-axis, you don't have any other choice except horizontal strips. I drew one horizontal strip over here, but then if you can see my strip, if I take my strip over here, because that's the integration that demands, that's the demand of integration over here. And if I allow the strip to move ahead, move on y-axis, after this point, my strip is going to change the behavior from left. And that is the reason I have to divide my region into two parts. So this is my strip. My strip goes up to here. No change in the behavior from left or right. Or I would say right and left. Here my right side remains same, but my left side behavior changed. And that's why I divided my region into two parts. Now, my axis of revolution is still y. It has to be the same. And my strip touches my axis of revolution. That means for this region, I'm going to use disk method. But for this region, my strip is not touching the axis of revolution, and that's why I'm using the washer method. Are you getting me, guys? That's why I told you this is the example in which you are using disk and washer simultaneously. Am I right?
Yes, sir.
Yes, sir.
Sir.
Good. So first of all, volume V, first part disk, second part washer. Right? First part, and that's why I told you yesterday, please be ready with your stimulator. Right? If you need some time, 5 minutes break, I don't mind, and grab your stimulator after this example, but please wait for some time. So 1 minus 0 square. Why 1 minus 0 square? Because x equal to 1, horizontal strip integration with respect to y, you have to have the function of y or constant, x equal to 1 to x equal to 0. So 1 minus 0. And rx square, so square and dy. I'm done with washer. Sorry, my bad. Disk. Washer. Washer means capital RY, means highest right side, most right side to the axis of revolution. So x equal to 1 to x equal to 0. So 1 minus 0 is my capital RY. 1 minus 0 is my capital RY. And here I am given y equal to x square plus 1. But I have to have the function of y. So x square equal to y minus 1. So x equal to square root of y minus 1 in the first quadrant. So x equal to, look at here, y, x square equal to y minus 1. So x equal to square root of y minus 1. So my small ry is square root of y minus 1 to x equal to square root of y minus 1 to x equal to 0. So square root of y minus 1. Square root of y minus 1. So here it is 1 minus 0 means simply 1. My capital of ry square minus my small ry square is this one. Does it make sense now? In this example, I did not write separately because I think we already took 3-4 examples based on cell method. So I think you guys are now to go. You guys are now very much familiar.
Can we zoom in a little bit on that?
You want me to zoom? That sounds good. Just give me a... Sounds good?
Yes, sir. Thank you.
No problem. Okay. So look at over here, x square equal to y minus 1, so x equal to square root of y minus 1. And then after just simple calculation, term by term integration will give you the answer 3 pi by 2. 3 pi by 2. Now I'm going to use my cell method. My cell method says that axis of revolution is same, figure is same, everything is same. Sometimes I may ask you, choose the method as per your convenience. For this example, I would say I divided my region into 2 parts because it was the demand, right? But if I, instead of disk and washer, if I go for cell method, I don't have to divide my region because my strip doesn't change the behavior. So that's why if I do like this, look at here. If I do like this, my top part of the strip, if I take this strip at the initial point, my top part of the strip is over here on the function, bottom part is my x-axis, y equal to 0. And if I allow this strip to sweep from this point to this point, there is no change in the behavior. There is no change in the behavior. And that's why I'm not dividing my strip or my region into 2 parts. Just one part is enough. So for this method, I would say for this particular example, cell method is more appropriate, more convenient than the disk or washer. It depends on the example. There is no rule like this that this method is more easier. No rule. It depends on the example, right? But for this particular example, I would say like this. So y equal to, now, first of all, I need to fix my hy. Always fix hy because that's the length of the strip. Length of the strip. Length of the strip hy equal to top to bottom, because we go from top to bottom always. My top function, my function now is a function of x because vertical strip is there, right? Axis of revolution is this one. I have to have this strip which is a vertical strip. Vertical strip is integration with respect to x. Sorry. Integration with respect to x. So y equal to x square plus 1 to y equal to 0. So x square plus 1 minus 0. So x square plus 1. That is my x square plus 1. Now, distance from the center of the strip to the axis of revolution, usually we consider this distance as x. I don't know why. I need some water, just wait. So this is x. Plug the values, 2 pi u, don't forget to multiply by 2 pi. X runs from 0 to 1, same point of intersections, term by term integration, fundamental theorem of calculus part 2, same answer. Look at here, guys. 3 pi. Happy? So that's what I mean by disk and washer method. I give you 2, 3, 4 minutes. I would say 4 minutes. If you have any doubt, we can discuss your doubt. Just keep your doubts aside. If somebody thinks that he is good with both of this method and wants to grab some stimulator, that's fine. I don't mind. So I would say it's exactly 8:45. Come back within 3 minutes or 4 minutes. 8:49, I'll be here, or we will be here. Go ahead, 8:49. Let me stop right now. This one. Video pausing. You are sharing the screen and
Sir, so what's the deal with the retake?
we will discuss after 3 minutes. Just wait.
Okay.
Oops. Where is the screen? $8.49. Okay, guys, start. Yeah, some question. Somebody was asking me a question. Go ahead. No question. Somebody was asking me something about the taste.
Yeah, I think Cooper was asking you about the retest, sir.
Okay.
What's the deal with the retest? Like, what do we have to do to retake it?
Let me do one thing. Those who got less than 70, they can solve the complete exam. Just go through each and every problem of the exam thoroughly. Don't write roughly. Sometimes people are using very small handwriting, and don't give me hard time, guys. It's hard for me. Virginia, are you there? Virginia, are you there?
I'm here.
Okay, listen to me carefully, all you guys. Yeah, don't use small handwriting. You are giving me hard time. Please, guys, use little bit big handwriting and don't use unusual symbols. Yeah, some people are using like this, like this, like this. So this means that I understood that is Y, and I was just wondering why it is Y. After 3-4 minutes, I came to know this. Oh, it's just a symbol. Don't do like this, guys, please. See, in my writing, you will not find anywhere any kind of improper symbols, unrelated symbols. So please, just do like this. See, equal to, below, equal to, like this. See, and that's it.
So for the retake, are we taking a retake or are we just correcting our test?
And for retake, I would say that this time, let me give you this facility. Just go through complete exams, whatever you had last time. Just go through complete exam, and then send to my email. Yeah. How many of you got less than 70?
I did at least.
I did.
Yeah.
I did, sir.
4, 5 guys. Yeah. Jonathan Soto, are you hearing me?
Yes, sir. That was tough.
So please go through this exam. See, I want you guys to clear this course with good grades. That's my only expectation. I don't have any other expectation, guys. So please do this thing, please. And that's for your benefit, right? I told you very first day that if you are failing this course, I will not be a loser. But if you are getting A grade in this course, I'm not going to gain anything. Right, guys? Please work hard. You know, if you guys clear this course with good grades, B or A, it's kind of little bit mental satisfaction to me at least. Okay, my students, they are doing well. Okay, good. And I would love to give you good grades. And that's why if you refer your exam, I gave you almost all you guys, I gave some extra points. Almost all you guys. Sometimes I have not mentioned, but you know, at that time you are entitled only for 2 points, but I gave you 3. I didn't mention sometimes, but yes, all guys, I give some extra points. I just would like to encourage you by giving some extra points so that, okay, I can at least, I'm on C. Okay, if I put some little bit more efforts, I can go to B. I can reach up to B. Like this. So that's the kind of motivation, but that motivation always comes through the hard work. So if you are working a little bit hard, and if somebody motivates you, yeah, you can jump from C to B, B to A. But you have to have that attitude if you want to improve. Anyway, guys, so yes, you are those who are 4 guys are there right now, right? So these 4 guys can solve complete practice test. Oh, sorry, my bad. Complete exam again, step by step. Should I trust you guys? You guys are not allowed to look at any of the materials while taking the exam. If you want to look at the materials before the test, I don't mind. That's fine. That's fine. But while taking the exam, be honest to yourself. If you are getting 100% in this exam, I'm not going to give you more than 70 because I don't want to do any kind of injustice to other guys.
Yes, sir.
If you think
Thank
that, oh my, yeah, I got 20, I got 60, and then if I took retake and everything is right, and even though you gave us 70, no, don't go for retake if you are expecting more than 70, because I can't do any kind of injustice to other guys. Please, guys, no way. Right? I just want you guys to come to that level so that you can also clear this course. Right? I just want to give you little benefit, but I can't do anything which is not good for. Hey, Chef Chris, are you stopping me? I like that sign. Stop. Chef, I like that sign. Stop.
Oh, you do, sir? Thank you.
Yes.
On my wall there.
Who are stopping?
That was a pretty neat sign. Figured it'd look
I know,
nice
but
on the wall.
whom are you stopping?
Buddy that wants to come in, I guess.
That's good. So nobody can come to your room, right? To disturb you. That's good. I like it.
Thank you.
Good. Where do you get this sign? From DMV?
No, I bought it at an antique store.
Okay. Good.
$5.
$5? Not bad.
$5.
Virginia?
Yeah.
We need to talk maybe after the class. You know, you missed the first test. And if you want to.
I emailed it to you. Did you not get it?
When? When getting problem when I'm facing problem getting your emails.
I emailed it.
Oh yeah, I think you get the email because of your first test, right? So
Yeah.
First of all, I would say that please try to go through all the videos posted on YouTube of first test. Go through each and every point. Go through all the practice test assignment. You need to submit your practice test assignment and your test. I'm going to change your exams. Whatever exam I give to other guys, it will be the different now.
Okay.
And you can take your exam.
I emailed the practice test and the first test to you. Did you not get that?
I am not accepting email for the practice test and the exams.
Okay, I can look back and rescan it and try to.
Please. Okay, good. Okay, guys. So that's all about the Scanwasser method. And now, plenty of examples are there. Look at over here. See, this is just for your practice. One of the examples, all these examples, they are from practices too. So one of the examples is like this. Look at y equal to 4 minus x squared. So this is 0, 4 because minus 4 minus x squared parabola opens down, passing to the point 0 and 4. Right. And if you take y equal to 0, that will give the x-intercept. So x-intercept is negative 2 to 2. And Wasser disk method, rx square to bottom. Rx is 4 minus x square and square. And answer, simple. But for the same, right now, my axis of revolution is x-axis. So disk method is good. But if I change my axis of revolution, look at my second example, second part, same example. Right here. Second part, same example. Now I change my axis of revolution. R equal to 4. Y equal to 4. Y equal to 6. Y equal to 8. But not x and y axis. X and y axis. Sheriff, what are you typing?
Somebody asked a question in the chat about the retake, sir.
Okay. Good. So now my figure would be same, but I have to use now the Wasser method. Wasser method means most top part Rx minus capital small rx, most top part to the bottom part, because we are coming from top to bottom. So it is 4 minus 0. So 4 minus 0, that is my capital Rx. And then my small rx is function. Yeah, it's a function. It's a curvature. Y equal to 4 minus x square. Y equal to 4 minus x square. So top to bottom again. So 4 minus x square. Don't forget bracket to justify the signs. So it is 4 minus 4 will get cancelled out. Negative, positive. So x square is there. Plug the values over here, rx square in the formula, and you can get the answer. About the line y equal to, another example, about the line y equal to -1. Y equal to -1. Okay, y equal to -1, that is the, now my axis of revolution that is below x-axis. Look over here, y equal to -1. My strip is same. You can take this way or this way, doesn't matter. Strip is same. So capital Rx is nothing but the top part, 4 minus x square to 4 minus x square. Look at over here. This is my strip, right? So capital Rx is 4 minus x square to y equal to -1. So 4 minus x square minus 1. Are you getting me, guys?
Yes, sir.
4 minus x square and minus 1. Minus 1 is plus 1. So 4 plus 1 is 5 minus x square. So 5 minus x square. Elberstone, are you sending some emails to me right now?
Yes, sir. I just checked the submission window
I will double check. I will check now.
Okay.
Not now, maybe in the afternoon.
Thank you.
Right now, please pay attention here.
Yes, sir.
Okay, so, and then Rx equal to small rx, that is nothing but the bottom part of the strip, right? Here to here. So here it is 0 minus minus 1. So it is 1. So it is 1. Just plug the values and get the answer. Plug the values and get the answer. Again, one more example. Oops, sorry. And probably the last example of these methods. What? Okay. Look at here, guys. Yeah, I like this example too. Y equal to x square parabola. Y equal to 4x minus x square. I took this example so many times. And if you remember, I told you that we are going to use this example at least 20 times. Do you remember this thing? I used this 4x minus x square in my Riemann sum. Do you remember that thing? Chapter number 5, 4x minus x square.
Yes, sir.
Still, I'm working with the same one. See? So 4x minus x square. And this is the strip. Axis of revolution is, where is it? About the line y equal to 6. See here, now my line y equal to 6 is just over here, y equal to 6. Because this 4x minus x square, that means this point is 0 and 4. Actually 2 and 4, right? If you solve these two equations, 4x minus x square equal to x square. If you solve like this, you're going to get x equal to, look at here, guys. You're going to get x equal to 0 and 2. If you plug these values in any one of these two equations, you're going to get 0, 0 and 2, 4. So these are the point of intersections for this region. Good. Line y equal to 6, nothing is mentioned. Let me use Wasser method over here. If I use Wasser method, so Wasser method says that v equal to pi integration rx square minus small rx square and dx. Capital Rx square minus small rx square. So here you can see my capital R, that is line y equal to 6. Y, top to bottom, y equal to 6 to this function. This function is y equal to x square. So it is 6 minus x square. 6 minus x square and square, rx square. Small rx is top to bottom, 6 minus this function, 6 minus 4x minus x square in the bracket, please. So 6 minus 4x minus x square. If you open this bracket, you're going to get this big expression. If you take perfect square, a minus b whole square, whole expression will be like this. If you cancel the common terms, term by term integration will give you the answer. Simple. So just play like this. Y equal to, see here, y equal to 6. Why not to take y equal to 7? I took y equal to 6. You can change the example, take y equal to 7 and try to find your answer. Same way, take y equal to 5, right? Try to find your answer. So this way you can just change the example a little bit. Don't change the functions, just change your axis of revolution. And that's the best way to practice. I solved over here by Wasser method. You can use cell method. Let's try cell method. What are you going to get? Right? Strip is the same. You are not dividing your region. So just one integral in both the methods, cell and disk, or cell and Wasser, what it may be. So that is the end of this disk, Wasser and cell method. The most important part from my side is over. It's now just you guys to go through all these stuffs again and again and again and try to get good command over these articles. Make sense?
Yes, sir.
Okay, guys. Now, the next article is the arc length. Arc length. I would like to continue for some time, and then after, let me stop sharing because I want to share the another screen now, another file. So stop sharing and let me open the another file now. My class notes and article 7.4. Where is 7.4? It's not here. Let me go back. And 124, okay. It's not here even. Practice test and practice test solution 7.4. Okay, guys. Here you go. Arc length. Most likely you guys are taking your exam on Monday. Okay, guys. Today is Friday. When you want your exam, Monday or Tuesday?
Tuesday.
Tuesday.
Why Tuesday? Why Tuesday?
Tuesday.
Why Tuesday? Okay, no problem.
Is the practice test up yet, sir?
Say again?
Is the homework or the practice test up yet, sir?
Yeah, it's already there in the file. I'm going to submit the extra full, because yeah, right now you can find the practice test in between the class notes, but I'm going to put the separate practice test probably today afternoon. Okay, separate practice test in your file folder in Canvas today afternoon.
Okay, thank you, sir.
Okay, guys. So now test is on Tuesday, and that is third test, and next Tuesday will be your last test, fourth exam, and I think Wednesday or Thursday, Wednesday final, right?
Yes, sir.
Thursday final, sir.
Say again?
Thursday final, I think.
Thursday, what's the
Thursday at
date?
2 p.m.
What's the date? Will you please let me know what is the date?
I believe it's June
June
18th,
18th.
sir.
June 18th,
1400.
June 18, 1400, 2 p.m.
Yes, sir.
Okay, June 18, 1400, that is the final for Calc 3. Okay, and DFQ, I will make sure with those guys. June 18, okay, that is Thursday, you said, right?
Yes, sir. So we'll have a test this Tuesday. And
Yeah,
the
this
following
Tuesday, and then following Tuesday, your next test, last test, and then after probably one day just for your revision or like this, and then Thursday. I think it's a reading day.
Thursday from 8 to 12 is reading day, and
Oh
then
my God,
2 p.m.
8 to 12 is a
starts.
reading day on Thursday. Okay, so teaching is there on Wednesday. Okay, no problem.
Yes, sir. So will you have graded test 4 by the time we take our final?
I don't know. I can promise you, because these 2 are the working days for me. After your class, I have to teach one more class, and then after I have to take care of those guys too. So if I find time, I will try my best. That's what I can say right now to you. I can
Yes, sir.
base that I can get back to you with your grades of 4th test before you get your final, right?
Yes,
Okay.
sir.
Thank you, sir.
Yes, sir. But yeah, it's just 2 days, hard for me, because if I have a hard paper to grade, it doesn't take more than 1 hour for me to grade whole class, maximum 1 hour, 15-20 minutes. But right now online, yesterday I spent 4 hours. Trust me, guys, because I have to type everything. I have to go to the cursor, I have to change the color, I have to put the balloon over here. So it's almost 3 to 4 times, more than 4 or 5. For one exam, it takes at least 15 minutes for me to grade. While hard copy, it doesn't take more than 3 minutes for me. Yeah. So just for one exam, I'm spending 10 to 12 more minutes. And then homework, same thing. So it's very time consuming for me, guys. If it is hard copy, I would have promised you, okay, you can get it back in very next day. But I will try, okay? Most likely, yes. Because I can understand that you have to have your grades with you before you take a final, so that you can ask me if you have some questions, right? I can understand that thing, guys. That's not your fault, yeah. I agree with you. Okay, arc length. Arc length means, suppose you are given something like this, some arc, some curvature in xy plane, x and y plane, and some curvature, suppose y equal to root x, right? I want to find just the length of this arc. If I give you straight line, you can measure the straight line very easily. But how can you get the length of the arc? How can you get the length of this arc? That is called arc length, one of the applications of integration. So y equal to fx, be a smooth curve on integration interval a to b. Then the arc length of the function between a to b is given by 1 plus y dash square dx. This arc length you are measuring with respect to x-axis, means you are you are integrating with respect to x. Actually, what we are doing, we are dividing our arcs. It is something like this, you know, guys. It is something like this. See, we are, suppose I want to find some length of some arc like this, So we are dividing, and this is from A to B. So we are dividing like this, number of partitions. It's a kind of trapezoidal rule like this. And then after each partition, now if you take very small partition, in that case, that curvature would be converted to straight line. So straight line, straight line, straight line, straight line, straight line, straight line, like this, right? So it is something like this. So 1 plus y dash square, square root, 1 plus y dash square, and integration a to b, that will provide you the length of the arc. That is with respect to x. Suppose you want to find the arc length with respect to y. In that case, you have to have the function of y. So it is not y equal to fx, it is x equal to gy. X equal to some function of y. And interval c to d. C to d runs from on y-axis. A to b runs on x-axis. So 1 plus x dash square dy. 1 plus x dash square dy. First example, I told you arc length is very simple. Only thing is, whenever you are taking the example of arc length, at that time you have to be very particular about the perfect square. I'm taking right now just one example, and then practice this example. The rest of the things we will be continuing on Monday. Right? Don't waste your time, guys. Please follow each and every words. Follow my instructions. Find the arc length of y equal to 1/3 x to the power 3 by 2, x to the power 1 by 2 on 1 and 2. Let me join my tablet over here. Probably that will help us a lot to find examples. Okay, so let me first write it down. Or you can write it down, guys. Just write down this first line in separate piece of paper and let me know. Y equal to 1/3 x to the power 3 by 2 minus x to the power 1 by 2 between the range of 1 and 2. Y equal to 1/3 x to the power 3 by 2 minus x to the power 1 by 2. Right? X to the power 1 by 2. Let me stop sharing and let me start my whiteboard. Okay. What was my y? Y equal to, yes, what was my y, guys? What's going on? Okay. Y equal to 1 by 3 x to the power 3 by 2 minus x to the power 1 by 2 on the interval 1 to 2. Am I right? Was it the same example?
Yes, sir.
Yes, sir.
Okay.
Yep.
Now, what is the formula for arc length? The formula for arc length is, yes, please. Arc length is equal to integration a to b, yes, please, square root of 1 plus y dash square and dx. So first of all, let me write my y dash. So y dash is equal to 1/3 derivative is 3 by 2 x to the power 1 by 2 minus 1 by 2 x to the power negative 1 by 2 power rule, right? This 3 and 3 will get cancelled out, means I'm going to get 1 by 2 x to the power 1 by 2 minus 1 by 2 x to the power negative 1 by 2. That means I can take 1 by 2 out, and here it is x to the power 1 by 2 minus x to the power negative 1 by 2. Agree? Yes or no, guys?
Yes, sir.
Now this is my y dash. I want y dash and square. So it is 1 by 4 and x to the power 1 by 2 minus x to the power negative 1 by 2 and square. That is equal to, please try to look at my writing, please. 1 by 2, and here it is x to the power 1 by 2 and square means x minus 2, x to the power 1 by 2 times x to the power negative 1 by 2 will get cancelled out. So just 1, and plus x to the power, yes please, x to the power 1 by 2 negative 1 by 2 square. So it is again, here actually it is x to the power 1 by 2, where is it? And y dash square. Okay, so x to the power 1 by 2. 3 by 2 to 1 by 2, 1 by 2, negative 1 by 2. That makes sense. Okay. And x to the power negative 1 by 2. Y dash square is equal to 1 by 4 and 1 by 2 minus 1 by 2 square. Okay. So x square minus 2 times and plus x to the power. What is that, guys? Negative 1 by 2. So here it is negative 1. Agree, guys? Negative 1.
Mhm.
Yes or no?
Yes,
Yes,
sir.
sir.
I'm getting 1 by 4, and here it is x minus 2 plus 1 over x. X minus 2 plus 1 over x. So that is my y dash and square. If I add 1, what I'm going to get? Because I want 1 over here. Look at here. I want 1 here. So if I add 1 both the sides, so 1 plus y dash square equal to 1 plus 1 by 4, and here it is x minus 2 plus 1 over x. So let me just write it down over here. So what I'm going to get, that is equal to 1 plus y dash square equal to 1 by 4 means 4 plus x minus 2 plus 1 over x whole divided by 4. If you simplify this one, you're going to get x plus 2 plus 1 over x divided by 4. And that is equal to, now this is important step. This is important step. How I'm going to write this one? X plus 2 plus 1 by x. Shall I write that is equal to x plus 1 by x whole square? Not x actually, root x plus 1 by root x whole square, because root x square is x plus 2 times root x and 1 over root x will is 2 plus 1 over root x square is 1 over x. Am I right? You have to make the perfect square. That is the only important step. Why I did this thing? Because y plus y dash square and I'm looking for square root sign. So if I go for square root sign, over here, this square and square root sign will get cancelled out, and I'm going to get very simple way x to the power 1 by 2 plus x to the power negative 1 by 2, so that I can integrate my function very easily. And that's why my arc length is equal to, my arc length is integration. You are given the range 1 to 2 because x runs from 1 to 2, and 1 plus y dash square is nothing but simply 1 over 1 by 2 plus x to the power negative 1 by 2, and here it is dx, and that is equal to x to the power 3 by 2 plus, divided by 3 by 2 plus x to the power 1 by 2 and divided by 1 by 2, and range of x is 1 to 2. Just plug the values. If you plug the value over here, x is replaced by 2. So 2 to the power 3 by 2. 2 to the power 3 by 2 divided by 2 by 3 here. Let me write. Plus 2 times 2 to the power 1 by 2. Big bracket complete. Minus, here it is 2 by 3 because x is 1. Plus it is simply 2. Simplify your answer, or you can use the calculator, and whatever the points you are going to get, calculator. Whatever the point you are going to get, that is, you may get some decimal number. That's fine. That is the length of the arc. That is the length of the arc. So what I did, just try to pay attention over here. I started with my, let me change the color if you want. Yeah, what I did, look at over here. I started with y dash. I took the derivative. I canceled the common terms. I got like this. Took common term out. Then I made the square like this. Perfect square I used over here. I added 1 because there was a demand from the formula. So I added 1 over here and I got like this. Then after that one, I just went over here. Look at here. So here 1 plus y dash square equal to this one. I took LCM and I got this one. But the most important thing is how to write this one in the form of the perfect square. So I wrote it down root x plus, every time you will be getting some perfect square terms like this, at least for our examples, whatever examples I'm going to provide you. Why perfect square? Because I am looking for square root. So if I make a perfect square, this perfect square and this square root will get cancelled out, so that I will be having very simple functions to be integrated very easily. Make sense? And that will provide you the arc length. Any doubt? Any doubt?
No, sir. No, sir.
No, sir.
Shall we stop over here? Whatever the article and examples are there in the practice test, try to practice these examples. And I will see you now on Monday. Those who have not finished their exams, I mean to say not submitted your exams and homework, if you want to lose your points, I can't do anything because this is, I think, almost 7th time reminder. Every lecture, I'm just reminding you 2-3 times. This is 7th reminder and I'm done. I'm just fed up. I can't do anything more than this, please. If you're not serious, if you don't want to submit the assignment, it's your choice.
Sir, I had a question about the retake.
Mm-hmm.
As far as turning it in and emailing it to you, is there a time tomorrow that you would like it done by, or would you like it just
That's a
done
good
anytime
question.
tomorrow?
No, anytime. That's your time. Anytime tomorrow, but before 6 p.m.
Yes, sir.
Before 6 p.m. That's your time.
Is there a specific subject line you want to? It's all pretty organized.
Specific subject line means what you mean. Let me stop recording.